Okay, converse of the Pythagorean theorem. The Pythagorean theorem states that if I have a right triangle, then the hypotenuse squared should be the sum of the two legs squared, respectively, right? So now if I have to do the converse, so this is the theorem that I have the triangle. The converse would be if I find out that the longest side squared equals the sum of the two shorter sides squared, then I must have a straight angle. Okay? Let's see how we use this. We have to determine whether these given triangles are right triangle or not. So the easiest way to do that is to square the hypotenuse and then add the squared legs together. So 3 and root 13, 3 root 13, if I square that, root 13 would become 13, and 3 squared is 9. 9 times 13, I have 127 on the left-hand side. On the right-hand side, I have, does not look like this add up. So obviously, if I add up this, I have 90 on the right-hand side. And since 117 doesn't equal 90, I cannot prove that this triangle given can stand the test of Pythagorean theorem. So no, this is not a right angle. Not a right triangle. Okay, let's look at the second one. I have, if this angle is, I really should put a question mark there. If this angle is a right triangle, I would have to satisfy the Pythagorean theorem. So this hypotenuse squared should equal to the sum of the two legs squared. 29 squared, I have to use my calculator. I have 841 on the left-hand side. On the right-hand side, 24 squared is 576. That I do remember. And then 16 squared is 256. So let's see. I don't think this adds up either. 576 plus 256. I have 832 on the right hand side, and then this is 841. So if I did my arithmetic correctly, this one is not a right triangle either, because the hypotenuse squared does not equal to the sum of the two legs squared respectively. Here is a theorem that Pythagorean theorem related to a Pythagorean theorem that can help us to determine what type of triangle it is. It states that if the square length of the longest side of a triangle is less than the sum of the other two sides, the shorter two sides. So if this is the case, then the triangle is acute. Otherwise, if the squared length of the longest side is greater than the sum of the squared length of the other two sides, so c squared is greater than a squared plus b squared, then we have an obtuse triangle. Obviously, if it's the equal sign in between, Pythagorean theorem determines that it is a right triangle. So this is a summary of all three combined. So the first one is Pythagorean theorem, c squared equals a squared plus b squared. If that's the case, then angle C is 90 degrees. We have a right triangle. If c squared, which is the longest side being squared, is less than a squared plus b squared, we have an acute triangle. If c squared is greater than a squared plus b squared, then we have an obtuse triangle. I want you to be aware of this. I know that we talked about triangle inequalities in chapter 5, I believe, where we learned something that if I have if I have any triangle, I'm trying to use the purple pen here. If I have any triangle, regardless what type of triangle it is, whether it's obtuse or right angle, the sum of the two shorter sides. So if I say this is C and A and B, this is equilateral, so it almost doesn't matter. And this is C, this is A and B. So if I say C being the longest side, we have a theorem that states that the longest side is always less than the sum of the two shorter sides. This one makes sense. If you think about it, that between this point and this point, the two blue points, C is a straight line. Whereas AB, if I have to add A and B together, it's like taking a detour to go from one blue point to the next blue point. So of course the detour is always longer regardless what type of triangle it is. So we mentioned this, we learned this in chapter 5 when we talked about inequalities of triangles. But here we're using Pythagorean theorem, which is c squared equals a squared plus b squared. Using this relationship, using this theorem, or related to this theorem, information related to this theorem to help us determine the type of triangle it is. So do not confuse the two concepts. One is to help us understand triangle inequalities, inequalities expressed in the form of side length or angles. The other one is helping us to determine what type of the triangle it is. So let's look at an example here. It says, can segments with length 2.8, 3.2, and 4.2 feet form a triangle? If so, would the triangle be acute, right, or obtuse? So what we do is we find the longest side, which is 4.2, and then we square that, and then we square the other two and add the two shorter sides together and see if they equal each other or which side is greater. So 4.2, this one I have to use my calculator. On the left-hand side, I have 17.64. And on the right-hand side, 2.8 squared, I have 7.84. Please make sure you check my arithmetic because I'm terrible at it. And this is 10.24. So if I add these two together, on the right-hand side, I have 1808. On the left-hand side, I have 17. So that inequality sign should be less than. 17 is less than 18. Therefore, yes, this is a triangle, and it is an acute triangle. Finally, this is a quick summary of what we covered in this unit, and see if you can fill in the blanks here. Okay, guys? Thank you very much.